All right, Algebra 1, we're going to do some zero exponents, negative exponents. These are a little tricky, so don't be afraid to ask for help if you're confused or get confused. Turn my board back on here. All right, let's see, page 503 is what we're on. Reciprocal. Reciprocal is if it's been a while since we've done it. We do have a fraction like 3/4. The reciprocal of that is 4/3. A number of times its reciprocal is always 1. So that's reciprocal for you. Okay, key concept, definition of a whole and negative exponents. So words, a to the 0 power is 1. So here's the algebra. I couldn't write the exponents. A to the 0 power equals 1. So another, like 5 to the 0 would be 1. Anything to the 0 power is 1. Okay? A to the, and I couldn't put the exponent, so I have to put it in right here. A to the negative n is the reciprocal of a to the n. So here's the algebra. A to the negative n equals 1 over a to the n. Okay, so 2 to the negative 1 equals 1 over 2. All right, a to the n is the reciprocal of a to the negative n. So a to the n equals 1 over a to the negative n. It's crazy. So 2 equals 1 over 2 to the negative 1. So they're just the opposites. These two right here are just opposites of each other. All right, so let's take a look. So 3 to the negative 2. Here's the deal. Negative exponents are not simplified. You cannot have an answer with a negative exponent in it. So 3 to the negative 2, according to the definition we had, it means it's the reciprocal. Whenever you have a negative, you do the reciprocal. So every time I have a negative exponent, I make a fraction. Okay? Now, the deal is that negative exponents need to become positive. But in order to become positive, they have to move from where they are. When that is written as a fraction, which would be 3 to the negative 2 over 1, if it is negative on the top, in order to make it positive, you have to move it to the bottom. So this is going to go down, become 3 to the second, and it's going to leave a 1. It's not going to be 0 up there, it's going to leave a 1. So that's 1 to the 9th. So anytime a negative exponent, you move it either to the numerator or the denominator, which is the opposite of where it is. Okay, which is a little different probably than the book explains it, but that's how I learned how to do it. So you look at this, and oh, this one's easy. This isn't a negative exponent, it's just 0. That's 1. No matter what the base is, if the exponent is 0, the answer is 1. Those are your easy ones. All right, so this is, first thing I'm going to do is simplify. It's going to be 1 to the negative 2 and 5 to the negative 2, just like we did in our powers. Now the deal, remember, in order to make it positive, or to make them positives, move them opposite. So to make this positive, I got to move it down. So it's going to be 1 to the second. In order to make this positive, I got to move it up. So it's going to be 5 to the second. So that's going to be 25 over 1, which is 25. It's hard to believe that that ends up like that. Let's see what happens. They did it differently, but I think my way is a little simpler. Okay, 0 to the negative 5, it said it can't be 0. So I think that we can't, because in order to simplify this, you'd have to have 0 to the 5th, and you can never have a 0 on the bottom. So that one is called undefined. So we can't do it. Okay, so let's evaluate it. First off, anything to the 0 power is 1. That's easy. This one, we need to make it positive, so we'll move it down, negative 8 to the second, leave a 1 up there. So it's 1 over negative 8 times negative 8, which is 64. Now look, that one's on the bottom now. There's our fraction. Now to make that positive, you got to move it up. So it's just going to be 8. 8 over 1 is 8. Again, 0 power is 1. All right, so let's look at a key concept, and I didn't write it because I can't do exponents on my paper. There's a lot here, so follow along with me. First off, we need to review all the powers we've learned. So we know when you multiply and your bases are the same, that you add them. Okay, that's the product of powers. Powers property. Okay, then we have a then we have a to the m to the n equals am times n. That's power of, I didn't spell that right, power of a power property. And then ab to the m is a to the m, b to the m, which is the power of a product. Kind of confusing, isn't it? Okay, these are from the last lesson. Okay, and then we had a over m. This is from, actually these are from I think 8.1 and this one's from 8.2. A m minus n. That's the quotient of a power property. And then we had, oh, this is actually, it's the same because they're going to get us ready for negative exponents. A, the parenthesis to the m equals a to the m over b to the m. That's the power of a quotient property. All of these are on page 504 because I know it's a pain to read my stuff here. All right, so we're reviewing that because we're going to use that here. So here, look, the bases are the same. So that's that product of powers property. So bases are the same. You add them. That'll be 6 to the 0 because negative 4 plus 4 is 0, which is 1. That's it. Okay, this one we multiply. It's going to be 4 to the negative 4. And we need to draw our line because remember this is like a fraction, so to make it positive it's got to go on the bottom. And 4 times 4 times 4 is 256. So 1 over 256. There's our, these get a little crazy. Now this one, because we want to make it positive, it's got to go up. So 3 times 3 is 9 times 3 is 27, so that's going to be 81. This one, in order to make it positive, this one's got to go down. This one's not moving because it's already positive, so it's going to join it. So that 1 is going to join the 2 down there and make 3. So 1 over 125. And they're subtracting them, but I don't do it that way. We got the same answer. So this one, to make it positive, we move it up. And 4 times 4 is 16 times 4 is 64. Okay. This one is the power to a power, multiply the two powers. So that's going to be 3, so 5 to the third, which is just 125. This one, the bases are the same, so we add the exponents. 5 and negative 5 make 0, so it's 1. Another way here is to subtract the exponents, or you just see this to be positive goes down here and joins that one. So I do not know what 6 to the 4th is. 6 to the 4th, 1296. So 1 over 1296. Simplify the expression, write your answers only using positive exponents. Okay, so it's going to get, this is a little crazy, but first off, on this one, I might do it different than what the book does. The 3 is on the outside, so it's just like we did before. You got to raise everything inside the parentheses to the third. So you're multiplying y to the negative 15. Now, positive ones stay put on the top. Negative ones go to the bottom. And that's 8. So 8x to the third over y to the 15th. So I'm going to simplify out the parentheses here, this exponent right here. So I'm going to get 2 to the negative 2 times x to the negative 2 times y to the 5th, all over negative 4x squared, I don't know, my pen's not working, y squared. Okay, so remember, negatives move, negative exponents move, not just negative numbers. So none of these are negative exponents. This is a negative exponent. It's got to move down here and join this one and become 4. So that one's gone. Pen doesn't want to write for some reason. This has got to come down here also, 2 to the negative 2 and become positive 2. So that's going to be 4. So let's clean up. This is gone. This one stays because it's not negative. So y to the 5th over, that's 4. 4 times negative 4 is negative 16. X to the 4th, y to the 2nd. Now, our y's, though, look at this. We can subtract those. And I do it this way. I go 2 of these, cancel out with 2 of those, leaving 3 on the top. So y to the 3rd over negative 16 x to the 4th. You can cancel just like with numbers, whatever's the same on the top and the bottom. And they probably did, who knows how they did it. They probably did it way different. But I betcha we're going to come out with the same answer. Look at that. There's the negative. Doesn't matter where it's hooked. It's the same. And you just have to practice them. You'll get good at them. The order of magnitude of the mass of the polyphemus moth larva when it hatches is 10 to the negative 3 grams. During the first 56 days of its life, the moth larva can eat about 10 to the 5th times its own mass in food. About how many grams of food can it eat during the first 56 days? So 10 to the 3rd times 10 to the negative 3 times 10 to the 5th is 10 to the 2nd. So 100 grams is what I say. We multiplied. I got 10 to the 2nd. That's 100. Excellent. Simplify the expression. Write your answer using only positive exponents. So right here, first off, these, let's just start with the numbers. 3 and 9 we can divide by, we can reduce these. 3 goes into 3 once, 3 goes into 9 3 times. The x's, there's one x on the top, which would cancel out with one x down here and make it a 2. This one, since it's negative, is going to join this 1 down here. So up here I have 1, only 1 left. 3x squared, because we made that a squared, and it's going to be y to the 4th, because those 3 join the 1 that's already down there, making 4. That's the easiest way I can make it for you right there. It's still confusing. If you have a question, ask. The order of magnitude of the mass of a proton is 10 to the 4th times greater than the order of the magnitude of the mass of an electron, which is 10 to the negative 27th gram. Find the order of magnitude of the mass of a proton. 10 to the 4th times greater. So 10 to the 4th times 10 to the negative 27. Add the exponents, 10 to the negative 23. And G for grams. G for great. I think we're done with 8.3. Have fun. These are, you can feel like you're doing them totally right, but just ask, because it won't take long for me to show you, and then you'll get it. All right? See you next time.